This fourth problem of developing a model is probably one of the most common problems that you'll see. So definitely pay attention to the rectangular field problems and practice those as much as you can. There's several examples given of them. So in this case, we're enclosing a rectangular field. We have Beth, she has 3,000 feet of fencing available to enclose a rectangular field. So they don't give us a diagram, but I think we should probably draw one. Okay. And we know that the fencing is the distance around the field. So in other words, if you see fence, you want to think perimeter. So the perimeter is going to be 3,000 feet. Okay, so we don't know, we know it's rectangle, so like whatever this side would be, this side will be the same, and whatever this side will be, this side will be the same. But we don't know that all four of them are the same. That would be a square, right? So we know if we want to do the perimeter, that would be 2x plus 2y, and that will equal our 3,000 feet. Okay, so this is kind of our constraining equation because we know things about this equation. So, you know, we actually we know it's 3,000 feet. All right, so let's simplify this equation a little bit just to make our lives easier. X plus y is equal to, divide by 2, 1,500. And then let's solve this equation for y. So 1,500 minus x, because typically we are going to, in the next part, when we write a new equation, we're going to need to put everything in terms of x or everything in terms of one variable. All right, so that was the given information, and here in part A it says express the area of the rectangle as a function of x. See, I've done these before, where x is the length of the rectangle. Okay, so we're trying to do the area. We know the area of a rectangle is base. Oh, I tried to be super clever. You'd see how good my rectangle is, but it messes up my writing because then it thinks that my writing is a shape too. Hey, I tried. I still enjoy how perfect my rectangle is. All right, so area is base times height. Okay, so in this case, the area would be base x times height y, right? But if we want the area in terms of x, just like we've done on other problems, we keep the x, but for y, we substitute what we know about x, or what we know about y. So right here, we have an equation to substitute in for the y. So we'll put 1,500 minus x in for y, okay? And then we're going to simplify this a little bit. You actually don't really have to simplify these, but if we're going to work with it a little bit later, we may want to have it look a little nicer. So I'm going to multiply the x into both terms. So that's 1,500x minus x squared. Okay. And then that is our answer to part A. And I'm going to highlight that equation because it's something we're going to use in a little bit. So it says, for what value of x? Okay, so for part B, we are looking for what value of x is the area the largest. So in other words, the maximum. If you look at the equation for area, hopefully you can tell that it's going to be a quadratic, right? It has an x, it has an x squared. Therefore, we are looking for the maximum. And the maximum is going to be the vertex, since this is a parabola. Now, you can do this the same way we did a couple others where we just put the equation for A into our calculator and then calculate the maximum using your calculator's calculate button. But this is a good one to just look at how you could also do it by hand. Since it's a parabola, you can use the equation h equals negative b over 2a to find the vertex, okay? So remember that A, you may want to always kind of write these down to the side. A is always the number in front of the x squared term. So these terms are out of order, right? The x term came first, then the x squared. So always try to notice that. So A is -1, and B is the number in front of the x. C is the third term, that constant term, and there's no number. So C is 0 in this case, if you needed it. All right, so here's 1500. Okay, so plugging that in, you get -1500 divided by 2 times -1. So that calculates to 750, right? Now this is where the maximum is, where the vertex is. It says for what value of x is the area largest? So our answer is 750 feet is our value for x. For part C, to actually find the maximum area, we would then just take our equation again and plug in 750 feet for x, right? That's how we find the k or the y coordinate of the vertex. So this would be the area at 750 feet. So that's 1500 times 750 minus 750 squared. Okay, so you can type that into your calculator. I already did, and I got 562,500. Okay, this is area, so this is, length times width, so it's feet squared instead of just feet. Okay, thanks.